All right, so for today, we're going to be working on section 3.6, part B. We'll just call it more curve sketching. Tomorrow, we'll do 3.6, part C, and we'll call that one even more curve sketching. I don't know what you say after even more, but much more, I don't know, but something. Yes, an abundance of curve sketching will be 3.6D if we have to. Um, but we're gonna work on just one sketch today, okay? And like I said, I've been trying to do some challenging problems. That way, when you guys see some of the more challenging ones in your book, you'll know how to handle them. Um, but let me show you this example here. So this will be example number 2, and we're gonna analyze the graph of f of x equal to x over the square root of x squared plus 2. Now I do want to give you guys a real quick reminder that anytime you're going to be doing curve sketching and it's a rational function and it has a square root in it, you usually will end up with two horizontal asymptotes. Okay? So that's kind of something you have to keep in the back of your mind, that I think I'm going to have two different asymptotes for the horizontals. So we'll deal with that right now, okay? But we want to go through our steps of solving for this stuff, right? So let's start off by listing a couple of things: our x-intercept and our y-intercept. We'll also do our vertical asymptote and our horizontal asymptote. I'm going to put those in a box. So let's see. That way we know like this is going to be a set of solutions for me. So to find the x-intercept, I told you guys yesterday, in order to find that, what you're going to want to do is you set y equal to 0. But if you're given a fraction, like we have right here, then all you want to do is set your numerator equal to 0, right? So if I set my numerator x equal to 0, then I'm done, right? X equals 0 when y is 0. So I'm going to put 0, 0 as my x-intercept. Now to check your y-intercept, it's actually not really necessary, because once you get a 0, 0, that basically is your y-intercept. But to get your y-intercept, you set x equal to 0. So this basically, if you started with that first, would look like this. 0 divided by the square root of 0 squared plus 2. And on the bottom, you get 0 over the square root of 2, which is a 0. So again, you'd get 0, 0. Again, just algebra here. I was telling the other class, my first period class, or second period, shall I say, not to freak out with a lot of the stuff that we do in this problem. It's all stuff you know how to do. It just looks more difficult, but you know how to do it. Okay, so just take your time with this stuff. Now, vertical asymptote, in order to do that, I'm going to write it over here, vertical asymptote. You're going to take your denominator, which is the square root of x squared plus 2, and you're going to set it equal to 0. And you're going to solve. So the first thing I'm going to do is I'm going to take both sides and raise them to the second power. So that gives me x squared plus 2 equals 0. And then I'm going to subtract the 2, so x squared equals negative 2. And at that point, hopefully you notice that's not possible, right? There's no solution. So if this has no solution, then that means that there is no vertical asymptote. Okay, so I'm going to put none on the vertical asymptote. Now for the horizontal asymptote, that's going to be a little new, a little different. Now the other class was able to figure this out. Let's see if you guys can do it. So here's your challenge. We're going to take the limit as x approaches infinity of x over the square root of x squared plus 2. Okay, now I did help them out a little bit. I gave them a couple hints. So I kind of walked them through this. Let's see if you guys can do it though. So what's my degree on the numerator? A 1, right? Highest power on the numerator, on the very top, x to the first, right? X to the first. Think about this next one before you say it out loud. What's my degree in the denominator? Yeah. What do you guys think? It's a 1. Yeah, it's a 1. Now, how is it a 1? Yeah, it's the square root of x squared, right? So that's going to become a 1. What's my coefficient in front of the x squared? There's a 1, right? So right here, there's a 1 right here. There's a 1 right there. So if you really think about it, you're looking at this information only, which is basically an x over x. Right? So what's your limit of that? It's a 1. Okay, this limit becomes a 1. So that means you have a horizontal asymptote at 1. But check this out. On the bottom, right, it'd be plus or minus. Because it is a square root. So it'd be square root of x squared, which would be a plus or minus 1x, right? Plus or minus 1. So my horizontal asymptote is going to be composed of 2 different asymptotes, one at positive 1 and one at negative 1. Okay, so this will be a plus or minus 1. Is everybody okay with that? All right, so yeah, I know it's kind of weird, but like I told you, anytime you see a square root and you're thinking asymptotes, think about plus or minus. So if, for example, if on the bottom I had the square root of 4x squared, then you would say plus or minus half. Because the square root of 4 is a 2, so it'd be a plus or minus half, right? If it was a 1 over square root of 9x squared, well then it would be plus or minus 1/3. Okay? So you still have to do the process of the square root to the coefficient, but make sure you include the plus or minus, okay? That plus 2 at the end, who cares? It's not affecting much, all right? So we're not worried about it. So great, we have our horizontal or vertical or x and y intercepts. All we got to do is figure out our critical numbers, our points of inflection, and we're done. Now I make it sound like that's the easy part. Not really. That's usually the hard part, okay? So let me write down the original function again. F of x is equal to x over the square root of x squared plus 2. And what I'm going to do is I'm going to simplify this for me because I'm going to have to take derivatives of this stuff. So I want to make the powers more manageable. So instead of square root of x plus 2, I wrote x squared plus 2 to the half power. Okay? So what I'm going to do is I'm going to take the derivatives back to back. I'm not going to worry about finding my critical numbers or points of inflection right away. The way I normally would do it is both of them at the same time. That way I get my work done quicker. So let's do my derivative. Now these are going to look really messy, okay? So try your best to keep it clean. I will do the same. But there's going to be some factoring that you might not be used to doing, but it's just factoring. We'll work with it. I'll try to show you how you can think about it to make it easier on your brain to kind of process it. But all right, let's start off with our derivative. Now notice this is a fraction, so I'm going to have to do a quotient rule. Okay, so the derivative of the top, I'm going to deal with this part right here, okay, with that function. All right, the derivative of the x is a 1 times the bottom. Okay, so I don't do anything to the bottom yet. And then minus the top, which is x, times the derivative of the bottom. Now the derivative of the bottom, it's x squared plus 2 to the half, so that half power has to come down first. Rewrite what's inside, don't even bother changing it. Okay, and then subtract 1 from the power, so that's a negative half. And then you have to do the chain for it. So right now we just did the power rule, but now you got to do the chain. That means the inside, x squared plus 2. The derivative of x squared plus 2 is 2x. Now all of that is going to be divided by x squared plus 2 to the half quantity squared. Now a power of half to a power of 2, so half times 2 becomes 1. So the bottom is just x squared plus 2. Now I'm going to cancel some stuff out before we move on. The half is going to cancel out with that 2. Again, I'm just trying to keep this as clean as possible here. So the first terms multiply to x squared plus 2 to the half minus. Now after that I get x squared times x squared plus 2 to the negative half divided by x squared plus 2. Now here's the part that's a little weird. I'm going to erase what I write down, but I'm just going to erase it because I want to show you something so you understand what's happening with this problem, okay? When we factor, okay, whenever we factor, so you don't have to write this part down. This just kind of watch so you can make sure you understand what I'm talking about. If I wanted to factor that, what would I take out? An x squared, right? So x squared. Now all you do to your powers, now to factor means to divide, right? But all you have to do with your powers is just say, okay, I'm taking out a 2, so 5 minus 2 is 3. So I get an x cubed, right? And then x squared minus 2 is x to the 0. That's why we get x squared x cubed plus 1, right? We just subtract. We're subtracting powers. Now, all right, great. We know that, right? You should know that already. No big deal. But what about if I give you like y squared minus y to the negative 3? Okay, the trick to doing this is to factor out the negative power. But you still do the same thing. You still subtract what you're taking out. So, for the first y, it's 2 minus negative 3. What does that become? A 5, right? This is a fifth power. 2 minus negative 3. And then what happens when I do a negative 3 minus a negative 3? That's a 0. Right? This is, you guys know how to do this. It just looks weird with negative powers. Okay? It looks really weird with negative powers. But it's no different than what you've done before. So, now that you've seen this, what do you think I'm going to factor from the top? The negative 1/2 term, right? So, x squared plus 2 to the negative half. Okay? So what remains of the first term, this first term right here? What's left over? It would be x squared plus 2 to the 1/2 minus a negative 1/2. Half minus a negative half. What is that? It's a 1, right? Half minus a half. That's a 1, right? That's half plus half. That's 1. So that means this is just x squared plus 2 to the first. Okay, and then minus x squared divided by x squared plus 2. Now things are going to get a lot smaller right now, okay? We're kind of working through this stuff slowly. So we took out that negative half power. Notice how the x squareds are going to cancel on the inside of that bracket. Right? Gone and gone. Now what I'm going to do, I noticed that there's two x squareds plus 2's, right? Terms. There's one on top, one on the bottom. Since this one has a negative power, I'm going to shove it down towards the bottom. So this is going to be 2 divided by x squared plus 2 to the half times x squared plus 2. This would be to the first. So what does that equal to? 2 over x squared plus 2 to the... What do you do with those powers? You add them, right? So what's half plus 1? 1.5 or 3 halves. There's my first derivative. The second one's a little easier. Okay? But that's my first derivative. I'm not going to do the sign graph for it yet. All right? Do I need to go over anything right now? That doesn't make any sense. Again, we're trying to factor out our negative powers. That's usually the trick to make things come out normal again. And as you can tell, it made it look really nice at the end. It wasn't that bad at the very end, but all the way through, yeah, it was a bit weird. All right, so then let's take our second derivative. So f double prime of x. Now we're going to take the second derivative of this thing right here, okay? So what's the derivative of 2? 0. So that's nice because it's going to eliminate one of these terms here. So 0 times x squared plus 2 to the 3 halves minus. Now I get to write the 2 there. And then I get to take a derivative of that bottom portion. So start with your power. 3 halves, x squared plus 2. Subtract 1, you get a half. And then the derivative of the inside, that's 2x. Sorry, I was almost going to write x squared, but that's 2x. And all that divided by x squared plus 2. Now, what happens when I take x squared plus 2 to the 3 halves to the second power? It just becomes 3. Yeah. 3 halves times 2 becomes a 3. All right. So check this out. This part is gone. This is going to cancel out because it's 0 times that. And then 2 times 3 halves, well, the 2 and this 2 will cancel out. So let me write the next step here. So we have negative 6x, x squared plus 2 to the half divided by x squared plus 2 to the third. Now again, you notice how they have the same base of x squared plus 2. So basically, I'm going to get the half power and subtract 3. That's a negative 2.5, or a negative 5 halves, or a 5 halves in the denominator. So this will become negative 6x over x squared plus 2 to the 5 halves. And there's my second derivative. Notice we're just dealing with bases and powers. You guys are good at this if it was in x squared plus 2, right? If I just had a bunch of x's and y's and z's all with weird powers, I know you guys can do, okay, subtract that, this is my new power here, etc. So don't let the expression mess with your head. It's just an expression, okay? Just work it the way you normally would work any type of variable with a power. Okay, so I know that's kind of the freaky part to this problem that scares a lot of people, but it's just normal algebra. That's all we're doing. Okay. Okay, just take your time, take a deep breath, push through. So here we go. So we can get to the graph. Yes. So 1/2 minus 3 is a negative 2.5, which is a negative 5/2, right? But that means that power would go up there. So that means you have to bring it down. So when you bring it down, it becomes x squared plus 2 to the positive 5/2. You could have also wrote it like this without that part. But then if I were you, I'd want to move it down, right? It looks weird when it's up there. So I'd rather move it down to make it look like something I can actually solve for. So it's up to you how you want to do it, but I don't know why you would want to do it where you keep the power negative.
Why did you subtract 3 in the first place?
Oh, it's because these bases match right here. So you take your power minus your other power, right? Whenever, like, for example, yeah, b to the 5th over b to the 2nd, you write b to the 3rd, right? Because it's 5 minus 2, right? So we just subtracted. Like I said, guys, this is, this. I know you know it. You just have to remember that you know it. If that sounds like it makes any sense. You got to remember that you know this stuff. All right. So here we go. Now this will be pretty quick, okay? All right, so I'm going to need your help here, because I don't want to be scrolling all the way up and down, over and over again. So, what were my critical numbers? Well, I don't know yet, right? So in order to get my critical number, I'm going to have to kind of do the work. So my first derivative, now if I'm wrong, correct me, but was it 2 over x squared plus 2 to the 3/2? Okay, so 3/2. So then I have to find my critical numbers. So in order to find my critical numbers, I set my numerator equal to 0, which, does that make any sense? 2 equal to 0? No, right? So that doesn't work. And then I set my denominator equal to 0 to see what makes it undefined. So that I can do. Okay. Remember, if you want, I'll put it right here. 2 equal to 0, but that's not true. Okay, so I can't figure that out. But the other one, if I raise the power to both sides by 2/3, it'll cancel my fractions. So it'll be x squared plus 2 to the 0, which is x squared equals to negative 2. Do you see anything that's a red flag right there? Yeah, I can't have a negative if I square something, right? Unless it's a imaginary number, but we don't deal with those right now. So there's no solution here. So that means there's no critical numbers. Okay, my critical numbers are none. So that means I don't get to put anything on that number line, but I still have to test it. So just pick any number to test it. Now, if I were you, I'd pick a 0. So what's f prime of 0? Is it positive or negative? Let's see, 0 plus 2. So the top is positive, right? 2 is going to be positive. On the bottom, 2 to the 3/2. Do you think that's going to be positive or negative? Positive. So it's positive over positive. That means this is always going to be an increasing function. It's going to increase throughout the whole interval. So if this happens to you where there are no critical numbers, then you have to just pick one, anyone, and check it. Are we okay so far? Anybody a little confused? We're good? Okay. Second derivative. We already did it. So let me just kind of mark this thing off here. So the second derivative, f double prime of x was a negative 6x over x squared plus 2 to the 5 halves. So I'm going to set my numerator equal to 0 and my denominator equal to 0. Guess what's going to happen when I set the denominator equal to 0? There's no solution, because eventually this is going to be the only thing left over. And when I move the 2 over, it becomes negative. X squared can't be negative, right? This is going to be a waste of my time to do. So I'm not going to worry about it. But the left side I can do. What's my answer for the left side? If I divide by -6, I get 0, right? So I get 0. So I'm going to put that up here. 0. So now I got to check to the left of it and to the right of it. So if I plug in a -1, okay, I'm just going to kind of help us out a little bit here because I don't want to run out of time. If I plug in a -1 into my second derivative, I get a positive answer. If I plug in a +1, I get a negative answer. Okay, I basically did f double prime of -1, f double prime of 1. Okay, concave up, concave down. So let's graph this thing. Now I'm going to go where every tick mark is a half, okay? So in other words, the ones will be like up here, right there, okay? I'm going by halves. I want the graph to come out kind of nice looking. So I start off by plotting points. So what's my x-intercept? 0, 0, right? What's my y-intercept? 0, 0. Do I have a vertical asymptote? Horizontal asymptote? Where at? 1 and -1. So here's the one at 1. Here's the one at -1. Okay. Now I know that my graph is supposed to go like this. Okay. It has to be increasing throughout the whole picture. And it has to pass through that point. But according to my concavity, it should be concave up before 0 and concave down after 0. So it's going to look like this. Concave up and then concave down. And there's my graph.